So over 2,000 years ago, a gentleman by the name of Pythagoras, who was Greek, discovered something about right-angled triangles. He discovered that when a triangle has a right angle, so that's a 90-degree angle, and squares were made up on each of the three sides of that right-angled triangle, then the biggest square had the exact same area as the other two squares added together. So in other words, in this image, the red square area equaled the area of the green square and the purple square. Now, C, you can see in this triangle, is the longest side of the triangle, and the longest side of a triangle is called the hypotenuse. And so the formal definition of the theorem of Pythagoras is that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. And so we need to remember this formula, c squared equals a squared plus b squared. So in the first example, we're going to calculate the length of the hypotenuse. And the hypotenuse, remember, is the long side, and the long side is always opposite that right angle. So if we draw an arrow from the right angle to the long side, we know that we're trying to work out what the long side is because that's where our variable is. And we know the lengths of the two short sides. So we know that we can use Pythagoras. So we're looking for the long side. So we're going to write Pythagoras with the long side on the left-hand side. So we're going to write c squared equals a squared plus b squared. Now, a is opposite angle A and b is opposite angle B. So we can substitute those values into the equation. So we know that c squared equals a, which is 8 squared, plus b, which is 6 squared. And if we add them together, we've got 64 plus 36, which equals 100. Now that's c squared, and we want to isolate c, so the inverse process of squaring is square rooting. So we need to square root that 100 to give us 10 centimeters. Now, we always need to go back and check our triangle to make sure our answer makes sense. And if we've got an 8 centimeter by 6 centimeter right-angled triangle, it makes logical sense that the long side could be 10 centimeters. If we'd forgotten to square root it and we had an answer of 100, we would know that we'd gone wrong somewhere and that we needed to go back and check our working so that our answer makes sense. So the second example, we want to calculate the length of the short side B. So this time we're going to again go to our right angle. We're going to draw an arrow to the long side. We've got a value there this time. So when we come to do our final calculations, we're going to have to do some subtracting. Now, the first thing we're going to do, we've got two sides and one unknown side in a right angle triangle. We know we can use Pythagoras. This time it's one of the short sides that is the side that I'm trying to look for. So I'm going to write Pythagoras' theorem as a squared plus b squared equals c squared. Now, let's look at the triangle. Side A is opposite angle A, so that's my 16 centimeters. Side C is opposite my right angle, so that's my 20 centimeters. So I can substitute those values in. So I'm going to end up with 16 squared. I don't know what b is yet, so I'm going to leave that as b squared, and that equals 20 squared. Now I need to do some rearranging, so I need to take away 16 squared from both sides. And that gives me b squared equals 20 squared, take away 16 squared. And that gives me a value of 144. Now remember, I want b, not b squared, so I'm going to say b equals the square root of 144. And that gives me an answer of 12 and my units again are centimetres. Now again, you want to go back and put the side length into your triangle, and I'm saying that side AC or side B is 12 centimetres, and that is less than 20 centimetres, so it makes sense. If I'd accidentally added 20 squared plus 16 squared, I would have ended up with a value that's bigger than my hypotenuse. Remember, your hypotenuse has to be the longest side, so that would be a red flag to make you go back and have another look at your calculations to make sure you've done it the correct way around. Right, my final example, I want to calculate the length of QR to 3 significant figures. Now you can see this time my triangle is called PQR. So I'm going to have to think about how I'm going to use Pythagoras' theorem with different letters. So let's go to the triangle first and work out what our sides are. So we want to work out QR. It's the side opposite P, so we're going to call that side P. Then we've got our other two sides. So our long side is going to be side Q, and so the other short side is going to be side R because it's opposite angle R. So I'm going to write P squared plus R squared equals Q squared using the letters on my triangle. Then I'm going to substitute in my values. So I'm looking for P squared. That's plus 12 squared, and that's going to equal 26 squared. I need to do some rearranging, so I'm going to take away the 12 squared from both sides. And so that gives me P squared equals 532. And if I wanted to leave it as an exact value, when I square root it, I can leave it as a third of root 532. However, if we look at the question, it's asking us to round to 3 significant figures. So we need to write down at least 4 significant figures and then do our rounding. So if I put that into my calculator, I'm going to end up with 23.06 and so on. And if I'm rounding to 3 significant figures, my third significant figure is that 0, and I'm using the 6 to decide whether I'm going to leave it as a 0 or round it up to a 1. 5 or more means I'm going to round up, so that means that my final answer is going to be 23.1. And my units are going to be meters.